Hello students, you all know that heart beats spontaneously, automatically and rhythmically without requiring any external stimulus. And what for it is? This is because heart has got a special type of tissues that is known as special junctional tissues. And the special junctional tissues present in the heart, you know that most important is the SA node. Besides this, there is AV node, bundle of His and Purkinje's fiber. Now, all these special junctional tissues of the heart, like the SA node, they can generate the electrical impulse. They can generate the action potential automatically without requiring any external stimulus. So, and this generating capacity of the SA node, this generating capacity of the action potential or electrical impulse of the SA node is responsible for automatic beating of the heart. So now here question comes, how this automatic generation of the impulse by the SA node takes place, how it is possible. So in this video, I will talk about these special properties of the heart muscle, of the special junctional tissues of the heart muscle, which is known as autorhythmicity. Autorhythmicity. And basically, this autorhythmicity, self-generating capacity of the electrical impulse by the special junctional tissues, like the SA node, is a special type of feature, is due to a special type of feature which is known as pacemaker potential. Pacemaker potential. It is also known as prepotential. So that means because of these special features, that is pacemaker potential or prepotential of the special junctional tissues of the heart like SA node, is responsible for automatic beating of the heart. So in this video, I would like to request you to watch this video till the end, and I will discuss here how this pacemaker potential or prepotential is initiated automatically, and that is ultimately responsible for beating of the heart, automatic beating of the heart. So what is this pacemaker potential? Pacemaker potential, these characteristic features of the SA node is due to the presence of a very special type of cells present in these special junctional tissues like SA node. And what is these cells? These cells are known as the pacemaker cells. So pacemaker potential is due to the presence of pacemaker cells. Pacemaker cells, also known as P cells. Now this P cells or pacemaker cells has got some important features. What are those features? First one, it has got, so features of these cells are, number one, it has low resting membrane potential. That is, in between minus 50 to minus 55 millivolt. You know that resting membrane potential in normal tissues, in neurons, it is minus 90 millivolt. But here, this resting membrane potential is very low, which is in between minus 50 to minus 55 millivolt. Second important features of these P cells, that is the unstable resting membrane potential. So resting membrane potential is not fixed, it is not steady, it is unstable, and this unstable is the slow falling of the inside electronegativity. So let us see this in the graph. This is duration in millisecond and this is in electromotive force in millivolt. So as I told, the resting membrane potential of the SA node or pacemaker cell is minus 50 millivolt, minus 50 millivolt. This is minus 40 and this is suppose 0. So now what's happened, as I told, the P cell has got unstable resting membrane potential. It is not steady. It is not steady like this. It is unstable. And what type of nature it is? From minus 50 millivolt, it is slow falling. It is slowly falling from minus 50 towards the minus 40 millivolt. So slow falling electronegativity inside is slowly falling, is getting reduced, and this is followed by relatively greater rate of fall of inside electronegativity up to the minus 40 millivolt, that is the firing level or threshold level. Now this entire thing, this is the curve, which is known as, this is the part of the membrane potential of the P cell is known as prepotential or pacemaker potential. So this slow falling inside electronegativity inside the P cell membrane is known as prepotential or pacemaker potential. So this is the, because of this unstable resting membrane potential, what's happened? This is slowly, gradually, inside electronegativity is getting reduced from minus 50 towards minus 40 millivolt, which is known as prepotential or pacemaker potential. Now, once this pacemaker potential reaches to a threshold level, reaches to a firing level. So this is the firing level. This is the firing level. This is the firing level. So at this particular level, that means once the pacemaker potential reaches to minus 40 millivolt, there is a initiation of the action potential, that is known as the spike potential. That is known as spike potential. And again there is a prepotential. Again there is a prepotential, and again there is a spike potential. So this is the prepotential, this part is the prepotential, and these parts are the spike potential. Spike potential. And because of this spike potential or action potential, because of this action potential, contraction of the heart muscle takes place. Contraction of heart takes place, and this is responsible for heart beating or automatic heart beat. So now here question comes, how this pacemaker potential or prepotential getting developed, and how this ultimately converted to spike potential that is responsible for beating of the heart. So this part is the Ionic basis. So third part I will talk about the Ionic basis of prepotential or the pacemaker potential. So first I will talk about the Ionic basis of the prepotential or pacemaker potential. Prepotential or pacemaker potential. How this prepotential or pacemaker potential is developed. So here you see, as I told, that in the pacemaker potential there are two parts, initial part and later part. So this initial part of the pacemaker potential, this part of the pacemaker potential, this is due to the opening of F channels or funny channels. So this initial part, that means the initial part of the prepotential, this is due to opening of funny channels or F channels. Now what is funny channels or F channels? Generally what's happened, the voltage gated sodium channels and the potassium channels are different. Through the voltage gated sodium channels, potassium cannot pass, and similarly through the voltage gated potassium channels, sodium cannot pass, cannot move. For both the ions, separate type of channel proteins are there. But in this case, what's happened? These channels, these leaky channels, these are the leaky channels. Sorry, these are the leaky channels. So these leaky channels are leaky towards both the sodium ions and the potassium ions. Both the sodium ions and the potassium ions. So these, and as these channels are open, what's happened? Sodium ions will also move. From which direction to which direction? As the sodium concentration is high in outside, low in inside, so sodium ion will move in. Sodium ion will move in, and potassium ion will move out. So through these funny channels, what's happened? So through these funny channels, the sodium ion will move in, and potassium ions will move out. Potassium ion will go out and sodium ion will come in. But the entering of the sodium ion, rate of entry of the sodium ion is little bit more than the rate of exit of the potassium ion. So net, there is a fall of the inside electronegativity, and thereby the electronegativity will gradually reduce from -50 to around, suppose, -45 millivolt. So this part, initial part, is because of the role of or opening of Fermi channels or F channels, through which sodium ion will move in, potassium ion will move out. Now what's happened at this particular point? Here you see, at this particular point, this is the point. At this particular point, what's happened? At the latter part, there is a opening of voltage gated T type of calcium channels. T type of calcium channels. So latter part, what's happened? In the latter part, this is due to opening of voltage gated T or transient type of calcium channels. So calcium channels will now open, and as the calcium channels are now opened, and as the calcium concentration is high in the outside, there is a movement of the calcium ions. Calcium ion will move in. Calcium ion will move in. So because of these things, what's happened? Calcium ion will move inside. And as the calcium ions are the positive ions coming inside of the cell membrane, P cell membrane, what's happened? Electronegativity will be further reduced to ultimately reach at -40 millivolt, that is the firing level. And once the firing level is reached, so this calcium ion will move inside, and this will result the further fall of electronegativity, to firing level, that is -40 millivolt. So now what's happened? Once the firing level is reached, as I told, the spike potential or action potential will be developed, and you know that spike potential or action potential is comprised of depolarization and the repolarization. So this part, this uprising part, this part is known as the depolarization, and this part is known as the repolarization. So spike potential is comprised of depolarization and the repolarization. So let us see now how this spike potential is developed once the prepotential reaches at a firing level or critical level. So now is the second one is the spike potential, ionic basis of the spike potential. So as I told, this spike potential is responsible for contraction of the heart, and thereby that is responsible for heartbeat. This is responsible for heartbeat. So heartbeat is because of the spike potential, and spike potential is automatically getting developed without requiring any external stimulus. So here spark potential or action potential is getting generated without requiring any external stimulus here. Here no stimulus, no external stimulus is getting required. Once the pacemaker potential reaches to the firing level, automatically the action potential is getting generated. So no need of external stimulus to initiate the action potential or spike potential that is responsible for heartbeat. So let us see now how this spike potential is getting developed automatically. So as you know that spike potential is comprised of depolarization and the repolarization. So depolarization of the spike potential, this is due to the, here you see the inside electronegativity is further decreased very rapidly from -40 to 0. That means the inside electronegativity is nullified, and this is because of the so this part, this depolarization, this is because of the opening of voltage gated L type of calcium channels, L type calcium channels. So here what's happened at this particular part, the voltage gated calcium channels used to open. So here voltage gated calcium channels used to open, and so depolarization is basically due to the opening of voltage gated L type of calcium channels, L type of calcium channels. As a result, what's happened? Calcium ion will rapidly come in. Calcium ion will rapidly enter inside the P cell membrane. So rapid entry of calcium ion inside the P cell membrane. As a result, there is a rapid fall of electronegativity inside. Rapid fall of electronegativity inside. So this rapid fall of electronegativity inside from -40 to 0. Next one is the declining phase or repolarizations of the spike potential. So next one is the repolarization of the spike potential. So next phase is the repolarization of the spike potential. So this is the depolarization and this is the repolarization. So at this particular moment, once the inside electronegativity is completely reversed, here what's happened at this part, there is a closure of voltage gated L type calcium channels. So at this particular moment, calcium channels, so at the peak, what's happened? At the peak, voltage gated calcium channels close, and as the voltage gated calcium channels close, there is a no question, so there is a no question of calcium entry or stoppage of the calcium entry. So there is a stoppage of the calcium entry. Calcium will not further enter. Stoppage of calcium entry inside. So calcium ion will not enter inside. At the same time, what's happened? This is the number one. Number two, second phenomena will take place at the peak phase of the spike potential. What is that? that is the opening of voltage gated potassium channels. So here, along with the closure of the calcium channels, potassium channels will open up. So second one is the opening of voltage gated potassium channels. And as you know that potassium concentration is high in the inside, so as and when these potassium channels open, so potassium ion due to concentration gradient will move up, will go out of the membrane, it will go from inside to outside of the membrane. So here what's happened, this results the potassium exit. So no more calcium entry is stopped, and because of the opening of the voltage gated potassium channels, there is a exit of potassium ions from inside of the P cell membrane. And as the potassium ions go out, obviously the electronegativity will again reappear towards the normal value, that is a minus 50 millivolt. So because of this, both these parameters, both these things, so both these factors are responsible for reappearance of inside electronegativity. So again the inside electronegativity of minus 50 to 55 millivolt will reappear, because in the one hand calcium entry is stopped due to the closure of the voltage gated L type of calcium channels, along with the opening of the voltage gated potassium channels, and these two factors ultimately is responsible for coming back of the inside electronegativity to the resting level, that is minus 50 millivolt. So this is how the spike potential is getting developed, and once the resting level potential will come back to the original value, that is minus 50, again the prepotential will be developed. So this is the second cycle. This is the first cycle and this is the second cycle. So second cycle of the pacemaker potential will be again initiated automatically, and that will cause the reaching of the membrane potential towards the firing level, and then again there is a initiation of the spike potential or another action potential, and that results the another heartbeat. And this is how the automatic heartbeat taking place because of the spike potential, and spike potential is taking place automatically, that is basically induced by the pacemaker potential or prepotential. So prepotential type of membrane potential is responsible for automatic development of the action potential, and this ultimately is responsible for contractions of the heart automatically without requiring any external stimulus. I hope the concept of the pacemaker potential is very, very clear to you. If it is so, don't forget to press the like button, share this video to your friend circle, and subscribe the channel who have not yet subscribed. Thank you.